The issue of nomenclature, or simply naming the compounds, is a very important one in organic chemistry. The reason for that is a lot of organic compounds. I think last week I mentioned there's more than 25 million of them. And in order to be able to identify them, we need to be able to name them specifically and unambiguously and not confuse them with any other compound. So the first couple of alkanes obviously are a good point to start talking about this because they're first-class organic compounds we talk about. And the first couple of alkanes have names that we already mentioned, such as methane, ethane, propane, and butane. And these names are historic, so there's really no straightforward explanation to why they are as they are. But the names after that, such as pentane, hexane, heptane, octane, nonane, and decane, come from Greek words which describe the appropriate numbers, so 5, 6, 7, 8, 9, and 10. You also might notice that all of these compounds have a suffix which is A and E, which simply indicates that the compound in question is an alkane. Okay? Now, as long as we have a straight chain compound, things are pretty straightforward. But things start getting a little bit more complicated once we start introducing branches into our compounds. And to illustrate this compound, a straight chain compound, is known as pentane. But if we introduce one branch into it, such as here, this compound is known as isopentane. And its prefix iso describes this terminal branch at the penultimate carbon atom. If we have two such branches, such as the case here, then this compound is called neopentane. And these three names are all very commonly used. Now the names isopentane and neopentane are the so-called common or trivial names. And while they are used very frequently, hence the word common, they become more and more difficult to create and remember for larger compounds. Because remember, with the number of increasing carbon, the number of isomers increases more than exponentially. So in other words, chemists very early on realized that they need a bit more all-encompassing system of nomenclature. And International Union for Pure and Applied Chemistry, also known as UPAC, has set a series of rules which determine how can we name organic compounds of pretty much any structure in a systematic, unambiguous fashion. And I will go through these rules, and then as we introduce new classes of compounds later on, we'll amend them with specific details for a given class of compounds. So the first UPAC rule is that we need to find the longest chain of carbon atoms. So this chain has to be uninterrupted. And then once we do find this longest chain, then use its name as the base name for the compound. Let me explain what I mean here. If we have a compound that looks like this, CH3, CH, CH2, 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 CH3, and here we have a branch which is CH2, CH3. It will almost inevitably be tempting to assign this as the longest chain. However, if we count the carbons here, then it's 1, 2, 3, 4, 5, and 6. What is hidden is that if we count carbons in this chain, then we have 1, 2, 3, 4, 5, 6, and 7. So we will name this compound as a heptane rather than as a hexane. And this is the first trick that you need to learn, and that is how to identify the longest chain in which can be and probably will be hidden. Now once we identify this longest chain, and this is again a heptane, the remainder of the molecule is called a branch or a substituent. Okay? In some cases we will have a choice between two longest chains which are of the same length, and in those cases you should choose the one with more substituents on it. Let me illustrate this with the following compound. So if you look at this compound, then the longest chain, and I urge you to consider the alternatives and really convince yourself this is the longest chain, is this one, which has 7 atoms. But one could also find a different longest chain, and I'll redraw the compound to make this clearer. And that would be this chain. And again, 1, 2, 3, 4, 5, 6, 7. So this again has 7 atoms. However, while this has 3 substituents, the structure on the right has 4. 1, 2, 3, and 4. And so the structure on the right would be the right one. The structure on the left would be the wrong one. The reason again is that there are 3 substituents here and 4 substituents here. Okay? Now that was the first rule, and again, with these rules, practice is essential. Rules themselves are simple, but if you don't practice, you will fall behind and they will become more complicated. The second rule is related to numbering the longest chain. So we will number the longest chain, but since it's a chain, we can start either on one end or the other. Which end we start on is determined by how close the substituent is. So number the longest chain, beginning with the end closer to a substituent. So we look for the first point of difference. Now in this same compound that we talked about, we of course now for the given longest chain that we already determined, we can start at either this end or at this end. If we start on the top, then our substituent will be 1, 2, in position 3, right? And so 1, 2, and 3. However, if we start on the bottom, our substituent would be in position 1, 2. Okay? So that means that starting on the bottom is correct, and starting on top is wrong. In other words, to redraw this now with the correct numbering scheme, the numbers will start here, and it will be 1, 2, 3, 4, 5, 6, 7. So now we both figure out which is the longest chain and where to start numbering that chain. The next rule is related to the substituents. because apart from just numbering the chain, we also need to deal with the substituents. And we're going to name the substituents as alkyl groups. And then number them. And we're going to number them according to the carbon they are attached to. So to review the alkyl groups again, CH4 gives rise to CH3, which is methyl because the carbon is methane. CH3, CH3, ethane, gives rise to CH3, CH2, which is ethyl. And for example, propane can give rise to two different groups. One which is attached on the central carbon, and this will be isopropyl, and one which is attached on the terminal carbon, which is here, and this will be simply propyl. Okay? Now, if we have a compound which has these groups in it, an example could be shown here. Then again, we would number this as 1, 2, 3, 4, 5, and 6 because that assigns this thing, this methyl group, the lowest number, and this will be 3-methyl hexane. Okay. Now, as I mentioned, some alkyl groups have common names. So, for example, this group, and I'm going to use the line angle formulas, is called isopropyl. If we add one more carbon, this will be isobutyl. If we do something like this, so connect this isobutyl group at one of these carbons, this will be the secondary butyl. And then finally, if we have this butane and then one of these carbons is still available for binding, this will be the T-butyl, also known as tertiary butyl. And these are the common names for some of the alkyl groups. We'll later on talk about the systematic names. But notice this S-butyl and T-butyl. These notions come from the fact that different carbon atoms are called differently. So this carbon atom would be methyl. But if we had the carbon functionalized group attached here, then this system will be called a primary carbon because it's attached to one more carbon. If a carbon in question is attached to two more carbons, then this is called secondary. And then of course if it's attached to three more, it's called tertiary. Okay? Substituents don't have to be necessarily alkyl groups. They can also be things like fluoro, so halogens, or chloro, or bromo, or iodo. And we name these just as we would alkyl. So we simply find their position in the carbon chain and then assign the number. So the same compound that we showed above, just with iodine replacing methyl group, would be called 3-iodomethane. Okay? Now the final rule relates to organizing multiple groups. And so here there are two actually sub-rules. The first sub-rule is that if you have two or more substituents, list them alphabetically. And the second subrule is if we have two or more substituents of the same kind, then clump them together and then use di or tri or tetra to indicate their multiple. So now I think we're finally ready to label our, to name fully our big compound from previous slides. I'm going to redraw it one last time. And again, we start numbering it from the bottom, 3, 4, 5, 6, 7. And then we look at the groups that we have attached. And so in position 3, we have an ethyl group. And then in positions 2, 4, and 5, we have 3 methyl groups, 2, 4, and 5. So it's trimethyl. And we already decided this compound will be a heptane. Now, because E goes before M in the alphabet, we will put ethyl in front of the methyl. And an important thing to notice here is that even though this has trimethyl, T does not count. We still take M as the indicator. This is especially important in cases where we have dimethyl compounds, where dimethyl group still comes after ethyl. So again, it's crucially important that you practice nomenclature often, because it will get very, very difficult very quickly if you don't keep abreast of it. Now, the final thing that we'll talk about will deal with naming complex substituents. And that has to do with the fact that in these examples that I've shown you so far, we only had one methyl group or simply methyl group or 2-carbon ethyl group branching off the main chain. But what if we have a branch that itself is relatively complicated? What if we have something that looks like this? So we have a long carbon chain, and then we have a branched branch, if you wish. Okay? So the central chain is still the longest one. It has 9 carbon atoms, so this will be a nonane. But the question is, how do you name this? And this, of course, can be dealt with using UPAC nomenclature. And so if we redraw this group, then we will still identify the main chain here. In this case, it doesn't matter because the two chains, the bottom one and the top one, are the same length. And in that main chain, the first position will be the one, and always will be the one that is directly attached to the main chain of the whole molecule, right? And so this will be position 1, this will be position 2 and 3. And so this group would be named as 1-ethyl propyl. So we treat it as a propyl group which has a branch itself, which is an ethyl. Now we put this whole thing in parentheses, and then we plug it into the name of this compound. So now, since it's on carbon 5, this would be 5. We'll keep it in parentheses to avoid confusion. 1-ethyl propyl nonane. Okay? Now, knowing this extension of the rule really allows us to name and number very complex compounds with very little effort. And so it's again, as I said, crucially important that you practice nomenclature. So practice nomenclature. We'll finish with the nomenclature of alkanes here, and now we'll start talking about their physical properties in the next topic.